Let's take a quick look at number 1 before you guys take off for the weekend here. It says a student on a skateboard with a combined mass of 78.2 kilograms. We're going to call the student and the skateboard object number 1. Moving east at 1.6 meters per second. As he goes by, the student skillfully scoops up his backpack. We're going to call object number 2 the backpack. What's the velocity of the student after the pickup? I was just talking to Kenton just a second ago. I said, look, when Kenton's wearing a sweater right now. Well, we don't consider Kenton and his sweater to be 2 separate objects, right? If we said, how much do you weigh, Kenton? What's your mass right now? What's your weight right now? Kenton would give me his mass right now. It would include his sweater. He wouldn't say, well, I weigh this, but my shirt weighs this, my tie weighs this, and my sweater weighs this, and my shoes weigh this. Right? He'd use his total mass, including all his clothes. Okay, so after this guy picks up this backpack, the total mass will be all one thing. The backpack will be all together with the student and the skateboard. We're going to call this M1. We're going to call this M2. We're going to call this V1I. V1 because it's object number 1, but initial. V2I. What's V2I? How fast is that backpack moving? Backpack is object number 2, right? How fast is that backpack moving before the collision has taken place or before he's picked up the backpack? Kristen? 0. It's at rest, right? It's at rest. We're going to find the velocity of the student and the backpack immediately after the pickup. So we're going to say PI is equal to PF. The total initial momentum is equal to the total final momentum. M1 V1I plus M2 V2I, because we have 2 objects before this interaction has taken place. 2 objects. There's the guy on the skateboard, that's 1 object. There's the backpack, that's the second object. But after it's taken place, they've stuck together. They've formed 1 object. So we're only going to put 1 term in there, MVF. Notice it says immediately after pickup. The reason we look at immediately before and immediately after is to allow us to have that isolated system. It doesn't give us a chance to have any external forces acting. In other words, it allows us to have that isolated system if we're looking at it just before and just after the interaction. All right, M1, 78.2 kilograms. V1I, 1.6. Cross that off. Why did I cross that off? Why did I X that out? Good, it's going to equal 0. V2I is 0, so whatever M2 is, 6.4 times 0 is 0. M over here is what? 84.6 kilograms. Why is it 84.6? Yep, add the 2 masses together. The kid picked up the backpack. Okay, the backpack is on his back now. Total mass of the kid is 84.6 kilograms. Solve for VF. Would you expect VF to be greater or smaller than the initial velocity of the kid? Smaller, right? He's now got more mass. He's got the same momentum, but more mass. He has to have a lower velocity. So we say 78.2 times 1.6 divided by 84.6 gives us a velocity of 1.5 meters per second. We expected it to be smaller. It is. Not dramatically, but it is smaller as we predicted. Does that make sense? So you try number 2 over the weekend. Okay, questions 1 to 13, those check and reflect questions that were due today. If you didn't get those done for today, okay, it's your get out of jail free today. You're going to have those done for the first of the week. Okay, I'll have a look at them now.